I will explain another way to subtract noise, where in the image if we see any particle sticks, something like that, if image is not homogeneous. If you take the image, say this is your sample, this is actually brain slice image. We took the image of the brain slice by putting the brain slice on top of the multi-electrode array, MEA. As multi-electrode array has the electrode, and electrode are very reflective, so sometimes we see the back reflection from the electrode, so we see the particle streak in the image, say something like that. Or if we look at another image like this image, we can definitely see that there are particle streak. These are the particle streak in the image. So if this is the case, then we cannot subtract the reference part, reference sum spectrum, because in reference sum subtraction we are subtracting the same amount in all the lines, but the noise in all the lines are not same, because there in some of the lines there are particle streak like here, but in the other part there is no particle streak. So it will not be fair that we are subtracting same amount of reference sum power or the reference on noise from all the lines. You can see from the depth profile of this data, if you look at the depth profile of this data, as depth profile is average, so in this area you cannot distinguish this kind of like smooth graph, where there is no indication that there are streak in the image. So we have to apply another method. So how can we do that? How can we subtract the noise in this type of image? So one way to do that is we have to subtract whatever noise amount from individual li. Say we are selecting the li number 250. Say for example we are selecting the li number 250. So to subtract the noise for this particular li number, what we can do is we can select some portion from the top of the image. So we are selecting say pixel number 1 to 40 here, and we can select some portion from the lower part of the image. Say we are selecting the portion from li number of say 230 to 250 up to that. Say we are selecting this portion and we are selecting this portion. Now if we average of this portion and this portion of the data, then that will take as a reference noise of this particular line. And if we do for another line, see here where there is a particle streak, similar way, that will be the reference noise for this particular line. As we see that there is a particle streak here, our goal is to make sure that when there is no tissue, say when there is no tissue, this part, there should not be any noise. Ideally, after subtraction of noise, the SNR of this part when there is no tissue should be 0, and when there is a tissue, there should be certain amount of SNR, whatever SNR it is. So if we subtract like individual lines noise, that means we are taking care of any kind of particle streak or any kind of unnatural thing that's only applicable for particular lines, then we are actually subtracting different way. Like we are subtracting whatever amount we are supposed to subtract from each lines. So this method you can apply only when there is a particle streak. This is the Also, you can do the same way for the image where there is no particle stick. You can also do that either way. So this method is the better method of subtraction of the noise. This method, I can call this method as subtraction from each line. We are taking care of individual line differently, not the previous method where we generated the depth profile for all the lines as one, and we subtracted the same reference arm depth profile from all the lines. But here we are subtracting different amount of noise for different lines. So that's definitely the better methods than previous methods.